Why do pool strips and purple cabbage change color with just a drop of acid or base? The secret is acid-base indicators, tiny molecules with big color flips. In this video, you'll learn what an acid-base indicator is, how color change intervals work, and how to choose the right indicator for different titrations, so your endpoint is clear and accurate. An acid-base indicator is usually a weak acid or base whose protonated and deprotonated forms are different colors. This equilibrium is the engine behind the color change. As the pH changes, the balance between the colored forms shifts as well. Around the point where pH is roughly equal to pKa, both forms coexist, giving a blended or mixed color. But once the pH moves past a certain threshold, one color starts to dominate. Most indicators changed color over about 1 to 2 pH units, centered near their pKa. That band is the color change interval. Examples: phenolphthalein turns pink in basic solution, or about 8.2 to 10.0. Bromothymol blue flips yellow to blue around neutral. Methyl orange goes red to yellow in acidic range. However, the equivalence point is theoretical, where moles of acid and base are exactly matched. The endpoint is when your indicator changes color. Choose wisely so the endpoint is approximately equal to the equivalence point. So far we've covered indicators are weak acids or bases. Their two forms have different colors, and the color change happens over a pH band near pKa. Ready to lock it in? Tap the link for study guides and flashcards on this topic, so you can keep learning without missing a beat. Now, selection time. Match the indicator's range to the steep jump on your titration curve. That's where a tiny volume change causes a big pH change, so the color flip is crisp. For hydrochloric acid versus sodium hydroxide, the equivalence point is at pH 7. Bromothymol blue has a range of 6 to 7.6, so it fits perfectly. For a weak acid titrated by a strong base, the equivalence point is basic. Phenolphthalein is ideal here. Acidic range indicators would flip too early. On the other hand, with a strong acid and weak base, the equivalence point is acidic. Methyl orange nails the color change right where you need it. Some indicators, like thymol blue, have two transition ranges. That's handy for different titrations. A universal indicator spans wide pH. Great for estimating, but too broad for precise titration endpoints. Here's what you need to remember, step by step. 1. Predict where the equivalence lies. 2. Compare indicator ranges to that region. 3. Pick the one that overlaps the steepest part so the endpoint matches the chemistry. Quick rewind. Indicators are weak acids or bases with two colors. Each has a transition range near its pKa. And you choose the indicator whose range overlaps the steep part of your titration curve, so the endpoint tracks the equivalence point. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet, content made just for you.